We're going to finish up quadratics today. We're going to look at the vertex form. So for a quadratic equation that is in the form that you see here at the right, in this form here, if it's in parentheses with something all squared like this, that means it's the vertex form. Your h is the x-coordinate of the vertex, and your k is the y-coordinate of the vertex. Notice it's the opposite of what's on the inside of the parentheses, but the same as what's on the outside of the parentheses. So let's go ahead and down below identify our vertex. So your vertex, once again, is the opposite of what's on the inside. So it means it's a 5. And the same as what's on the outside. And so then that's a -2. So when we are graphing this, and by the way, this is our vertex, remember your axis of symmetry is always x equals then the x-coordinate of your vertex, which was 5. Hopefully you remember that if it's a negative in the front, negative before the squared, it opens down. So your direction of opening, we're going to say opens down. So we have our vertex that we identified here, axis of symmetry, direction of opening. All we have to do now is graph it. Now, you can go ahead and use Desmos to get your points if you want. Remember, you want to choose at least 3 numbers on each side of your vertex. So I had already gone to Desmos and got my table. So we'll uncover that. And then here's the coordinates for that. Notice this is my vertex right here, and I went at least 3 points on each side of it. So I plot my vertex over 5 down 2. And then I can plot this one here over 4 down 3. This one here is over 6 down 3. Then we can go ahead and plot this one here over 3 down 6. And then this one here over 7 down 6. And the top point right here, that's going to be off my axes, so I'm probably not going to include that. So when I sketch this, it's kind of a U shape. So it's going to be a nice smooth curve going through your points like this. So that's what your graph would look like. So on the next problem, we pretty much have to do the same thing. We need to identify our vertex. So our x-coordinate is the opposite of what's on the inside, which would be a -4. And our y-coordinate of vertex, when it's in the proper form, is the same as the outside. So this is our vertex. Our axis of symmetry, remember, is always x equals your x-coordinate of your vertex, which was at -4. Now, because we are having a positive number in front, our direction of opening is up. So then we can go ahead and make our table, and I got my table out of Desmos. We've used Desmos before, so that's why I'm not plugging it in. You guys can always pause the video and go there and do the same thing. And then notice we went ahead, or I went ahead here, and got at least 3 numbers in each side of my vertex. And so we can go ahead now and plot that. 4 to the left and down 6. Then we can plot the next one, 3 to the left and down 5. 5 to the left and down 5. 2 to the left, down 2. 6 to the left, down 2. And then we can do this one here, 1 to the left, up 3. And then this one here, 7 to the left and up 3. And then we can draw in a nice smooth curve going between these points. By the way, it's easier to draw on paper than it is on a computer screen. That's the rough sketch of your graph. Now, having a parabola in vertex form makes it very easy to graph, and that's what we were doing here. Well, how do you actually get your equation from the normal form? I would say the normal form is like y is equal to some number times x squared plus another number times x plus this. That's your standard form. To your vertex form that we were just looking at. Well, you need to go ahead and complete the square. The completing the square steps here are pretty much all identical to the completing the steps we did before, with the exception of our last line. Here is something different. When we were doing completing the step before and solving equations where it was equal to 0 initially, we needed to solve for x at the end. Here, the only difference is once we get everything in the proper form, after we do our factoring, we need to go ahead and finish getting y by itself. So let's go ahead and try completing the square on a problem. So we have to go ahead and do our first step, which is get the 136 to the other side. So I'm going to go y minus the 136, so subtract that from both sides. Then we need to go ahead and get the number in front of your squared term to be 1. So there's a 2 in front, so I have to divide by 2. But I have to divide everything by 2. And so I end up getting a y over 2 minus, in this case, this 136 over 2 does simplify down to a 68 equals an x squared minus a 16x. Well, now I'm going to go ahead and add my blank spots, just like we were doing before. And then we need to go ahead and add half of b squared. 1/2 of b, remember 1/2 b is that 16. That's what's in front of our squared term right here, or not our squared term, our x to the first power. And so we get 8. So we have to then square it. So we have to take that 8, which is half of b squared, and then square it. Add it on both sides. So when we simplify the left side, by the way, your negative 68 plus your 8 squared is a minus 4. The right side will factor into an x minus 8 and a second x minus 8. So we could just write the right side as an x minus 8 all squared. So that was our factoring. So now we got to go ahead and do our last step. Our last step says we need to go ahead and get y on one side by itself. So I'm going to go ahead and add 4 to both sides. We get y over 2 is equal to our parentheses, all squared with a plus 4. And then I need to go ahead and get rid of my dividing by 2. To undo dividing by 2, I'm going to multiply by 2. And that affects the parentheses and what's being added or subtracted to the parentheses. And so we get a plus 8. And so that would be in vertex form. All the directions we're asking us to do is to get it into the proper form. Now it's in the proper form. If we needed to do more like we did on the last few problems to be able to find the vertex, axis of symmetry, and all that, we could. Let's practice one more problem. So we'll do our first step. So we'll go ahead and add that 29 to both sides because we have a minus 29, so we have to undo that. So I'll add 29. And then I got to get rid of that number in front of my squared term. Right now it's being multiplied by a negative 3. So to undo that, I'll divide everything by negative 3. Now, this 29 over 3 doesn't work out to be a nice, neat number. So I'm going to just write it. And by the way, a positive over a negative is a negative. So that's why it's just minus 29 over 3 equals a positive x squared. Negative 18 over a negative 3 is positive 6x. So then I'm going to go ahead and add my blank spots, because that's the third step. Now, the fourth step says I need to take half of b. Remember, b is what's in front of your term to the first power, so I have to take half of 6, which is 3, and then I have to square it. And it says we have to add that to both sides. So now, once I've done that, I have a y over a negative 3. Now, I would take the negative 29 over 3 plus 9, type it into my calculator, and when I do that, I end up getting a minus 2/3 or a negative 2/3. The right side is going to factor into an x plus 3 and a second x plus 3. So you could write the right-hand side as an x plus 3 all squared. Now we have to do our last step. We need to go ahead and get y by itself. Well, to get y by itself, we have to get rid of that 2/3. It's negative right now, so I'm going to add a 2/3 to both sides. And then I have to undo my, to get y by itself. Oh, okay, what happened? Sorry about that. To get y by itself, I need to undo my divide by 3. To undo divide by 3, I'm going to times everything by 3. Multiply the left side by negative 3. That means I got to multiply the whole right side by negative 3, which includes our parentheses and our negative 2/3. So now when I write this, I get y in the left. I get that negative 3 in front of my parentheses, all squared. A positive times a negative is a negative. 2/3 times 3 is 2. And so now we have it in the proper form for the vertex form. One small problem left that we need to do. So here, you're given your vertex, you know a point it passes through, and you need to write the vertex form of your equation. So as you can see here, I put in our vertex form. And so since we have our vertex, that means we know what h is and k are. So here, this is our y-coordinate of vertex, which we know goes there. So I'm going to go ahead and just plug those in. Y is equal to a times x minus, and I'm going to plug in my h, which is that 8, plug in my k, which is that minus 9. Now, all I have to do is find a, because when we looked at our initial vertex form here, we didn't know the h initially, we didn't know the k, but we had that from our vertex that we were given, but we still needed to go ahead and we didn't know what a is. So we still need to find a. But we have this other point. Remember, that's an x and this is a y. So I'm going to go ahead and try to find a. I'm going to go ahead and plug in my x-coordinate of my vertex, which is this 11, because that's my x. So I'm going to plug it in right here. And this is my y-coordinate of my vertex. I'm going to plug that in for my y right here. So now all I have to do is go ahead and solve this for a. So I get negative 18. When I look at what's in the parentheses, 11 minus 8 is 3. Then I have to square it, and then it's multiplied by a. So I get a 9a, still with this other 9. So to finish solving it for a, I need to go ahead and undo my minus 9. And I get a negative 9 is equal to an a times 9. So now I got to undo timesing by 9, so divide both sides by 9. And I end up getting a to be negative 1. So I'm going to go ahead and rewrite this line here. I'm going to go y equals, plug in my a value, which we just figured out to be negative 1 for my a value. And whether you leave it as a negative in front or a negative 1 won't really make a difference. And then go x minus the x coordinate of your vertex, which was at 8, and then put in our y coordinate of our vertex, which was minus 9. And hey, that's all we had to do. We got it into vertex form.